Thanks for joining the webinar today. My name's Justin Olivier, and I'm your host for today. So thanks again for joining. This is one of our first virtual strategy days in South Africa in a webinar format. Just by way of introduction, my name is Justin Olivier, and I'm one of the enterprise account managers here based in South Africa. So today we've got quite an exciting agenda lined up. Obviously, the topic is going to be zero trust security. And in order to discuss this in greater detail, we've got HashiCorp CTO, Guy Sayer. Guy's going to explain how to successfully implement zero trust using HashiCorp technology. And then Guy is going to be moderating a panel along with Johan Marais and Carl Fisher. Johan is from Discovery Limited. He's one of the senior platform services managers there, and Carl is the CTO for Obsidian. Both of these guys are going to share their experiences, how they've in terms of how they've implemented zero trust strategy across their organizations, their cultures, security practices, and tooling and such. And then after that, Lance Haig, who is one of HashiCorp's regional managers in our solution engineering team, will be sharing an overview of the HashiCorp roadmap to zero trust. So, this just to let you guys know in terms of a bit of housekeeping, this webinar is going to be recorded. The recording will be made available post-processing, usually around about 2 or 3 business days. We'll get that out to everybody that joined. And if you have any questions as we go through, we can keep this interactive. Please post them in the question box. And then during the Q&A session at the end, we'll answer as many of them as we can. If we run into too many questions, we run out of time, we're actually going to continue the conversation in a Zoom meeting thereafter. So you'll have a chance to keep asking questions. We'll paste the link to the continuation for the Zoom meeting in the chat box for the webinar. So with that, let's jump into this. Welcome everybody, and I'm going to hand over to Guy. Thanks.
Thank you, Justin. Hi everybody. Thank you for having me today. I'm just going to share my screen 1 second, and I'm gonna talk about zero trust today. Yeah, and there are 2 parts to this talk. The first part kind of go through some history, what has been going on-prem data centers and typical approach to security and application and infrastructure security, and then kind of look at how cloud adoption and transformation impact security. And then the second part, we're going to look at our approach, at HashiCorp's approach to addressing zero trust, and kind of look at the different products that we use to implementing the strategy. So just before we start, for those who are not familiar with HashiCorp yet, we operate in a few areas in the cloud infrastructure and automation domains. Our portfolio addresses provisioning, securing, connecting, and running use cases for managing applications in multi-cloud environment. And today we're focusing on the security part, and that is the combination of Vault, Console, and Boundary. Okay, so taking a step back and kind of looking at traditionally how on-prem private data centers have been secured, right? And we kind of say it's easy. Nothing is easy, but what we want to say here, it was sufficient to secure the perimeter of the data center, right? This notion of castle and moat, where the entire focus is on the ingress of the data center. And we could do that because organization had full control, soup to nuts, right? From the actual building and walls and the compute and network and everything else, all the way up to connectivity. And with that model, you really sit there with firewalls and WAFs and C middlewares and focus on making sure that there are no bad actors accessing the network. Sometimes you'd have like additional network perimeters near DMZ and far DMZ with reduced functionality, just to make sure that no bad actors make it into the network. And that kind of makes an assumption that if you are on the network, you are not a bad actor. You have good intentions, right? And if you kind of carry that on to how applications have gotten used to operate, kind of looked at security checks at the very end of the process, and typically looking at the findings and even sometimes accepting them as technical risk debt, so that we don't impact delivery timelines, and we'll come back sometime in the future to address those. And that was all fine. That was all okay because of the very fundamental assumption that someone else is securing the environment, right? Someone else is sitting there and protecting us. And with this model, it's okay to be less strict, a bit sloppy with security. It was not okay, but we accepted and we learned to live in this with this model, right? And then cloud came and kind of flipped this thing on its head, and we'll talk about why, right? And with cloud, I'm going to call out 3 main things that are impacting zero trust and security. It's a very wide topic, right? Cloud transformation, but specifically when we zoom in on security and trust, we talk about these 3 main areas. The first is what we call the understanding of the perimeter. And our approach is that we need to work with perimeter-less strategy in mind, right? And the reason is that with multiple clouds, multiple venues, we as an organization, as technologists, we don't control the network. We instruct, we direct, we request, and then we kind of assemble a logical network from different portions of networks that are controlled and managed by third parties, different providers, different clouds, different organizations, right? So now we have this different low trust, high trust network, public, private, and if we overlay application migration and cloud adoption on it, we kind of always have some on-prem core services and compute. Net new will be cloud, and some will be migrated, refactored to the cloud. So all of a sudden, we have this need to connect and access and link different networks with different trust levels, right? So we have something running on a low trust over the public internet, but needing to access and integrate with on-prem secure environment, right? So that's kind of the first fundamental change, the understanding of the perimeter. There is no perimeter anymore, and we need to operate in this, what we call the hostile environment. The second driver is this, what we call the user workflows, the focus on self-service, the agility, the CI/CD, the DevOps, the place where cyber and security can no longer keep with the pace, can no longer be there as a gate and block the process, slow the process, but rather now cyber become an enabler, right? So if you think of how cyber operate in this environment, is to be more defining and managing control, governance and controls, and then kind of stepping out of the way to let application teams to comply and integrate and check with. Right, so it's a different way to implement zero trust. It's cyber are not there on the critical path to control and block the process, but also we need to provide higher level of securities because of the hostile environment that we operate in. And then the last portion is the, when you think of attack vectors and how we kind of gotten used to, and I said before, if someone is on the network, we assume they have good intentions. There may be mistakes or bugs or issues that would cause security concerns, but we assumed over the years that someone that is on the network, a process or a human or a service, have good intentions. They should be there, and for that reason, we will give them access to do whatever they ask for. In the new world, we are in a hostile environment. The fact that you are on the network grants you no access or power to do anything, right? Everything needs to start with some way of managing the interaction with someone on the network. So we kind of look at attack vectors very, very differently. It's no longer perimeter, bad actors attacking us from the outside, but we have attackers attackers on the network, and we'll talk about the implication of that to various layers of the stack. So moving on, I'll talk about the three main changes that we see kind of reacting and adapting to the cloud in zero trust setup. The first and foremost, right, we kind of talked about the attack vectors. The first is that we kind of move away from managing identity at the physical layer, at the IP layer, MAC addresses, and so on, to something different, something logical. Every interaction now needs to start with establishing identity. Everything needs to be authorized, authenticated, and authorized. The fact that you are on the network and you have access, physical access to a service, to a network, should grant you nothing, should give you no access or power to do anything, but rather you start with kind of presenting your identity, authenticating yourself, and then if you are authorized, you'll be led forward. And this is really because we're now in this world of multiple network, dynamic environment, right? We don't control network addresses. We have dynamic and modern technology stacks like NAT addresses and Kubernetes stacks and whatever else. We can no longer rely on the physical identity of machines. So we need to think about something at higher level, some logical identity. And if we establish logical identity, the first step for establishing the identity is this notion of authentication and authorization. The second part that we talk about is the just-in-time secrets, right? And this is, think of a wide spectrum where we start, right? Typically, we start with hard-coded keys and username and passwords in config or code file, and then all the way to the right, where we envision on-demand ephemeral identities and credentials. Right, so this is kind of a nirvana state, but we want to move from left to right and move away from hard-coded, store them in a wallet, do something dynamic, and kind of move to this world that as workloads and infrastructure are ephemeral and are created on demand, so should identities and credentials be. And then the third part, the third and last, is encrypt everything. So, and this is the move away from existing traditional ways of using transparent disk encrypt, right, where we use appliance and we kind of hide this from the application or the database even. And then, if you think of our attack vectors and our neo constraints, we know that we're going to have bad actors of the network. And transparent disk encrypt, if you access it through the application or through a database, will happily decrypt. So we need to think of data protection in a different way, in a new modern way. This is where we, logically speaking, we elevate encryption to the application level, and the application would write and read encrypted data, and then all the decryptions happens in memory, and also the interaction between applications all need to be over encrypted channels, right? So all the communication and all the data that data in transit, data at rest, has to be encrypted, but not transparently. This is something that is done with application awareness, right? This is a key differentiator to how we do it today with transparent disk encrypt. So, we kind of talked a little bit about the history and existing data centers and some assumptions and over the years and what we did. And, we never liked it, but it was okay. And we need to react and change. And cloud transformation and adoption is really a big driver for that. And in the next section, I'll cover our approach to zero trust and how we implement it with our security tools, Vault, Consul, and Boundary. We kind of break the problem into 4 pieces. And we look differently at machine to machine to human to machine. At the high level, it's the same strategy, but you'll see that the requirements are a little bit different. Even the use cases are different. If you think of a user to machine, it's usually a break class or maintenance, whereas machine to machine, it's an ongoing BAU interaction that exists, right? The overarching for all this story, and this is the most important point of this talk, is this move away from physical IP-based identity to logical and identity-based identity. And we'll see it, when we go through the boxes. I'll cover them. I'll start at at the outside and then kind of move in. So I'll start with human to machine authentication, right? That's probably the easiest one for me to go through, right? And you can think of over the years, organizations have evolved. And there's been consolidation of identities, both authentication and identity providers at organizations, at enterprises. And it's very common to use single sign-on today, right? So typically a journey starts with authentication on some LDAP or Kerberos or Active Directory on-prem. And then that identity is carried with single sign-on to the target platform, right? With Okta or Ping or whatever else. And really with cloud and with our approach, there's not much new here. We join and piggyback this existing mechanism to establish identity for humans, right? So I'll now move to the other side and talk a little bit about the machine-to-machine authentication. And for that, we use Vault. Vault is it's a category leader. It's our leading security product, and it addresses three main use cases. The first and simplest one is secret management, right? Just think of using Vault as a wallet. And this is your first step from that hard-coded secrets and keys in code and configuration file. You just move them to Vault. And then the next step is to kind of use dynamic secrets with Vault and enhance the usage. The second and third use cases are around data protection, data encryption and data protection. And this is where we talked earlier about elevating the encryption to the application level and the way Vault kind of fits in. So if you think of the application reading and writing data from persistent store, it's all encrypted. And with the help of Vault, it would be decrypted for read and encrypted for write. Right? And Vault also kind of has notions of transforming and transposing data to fit into various data constraints that exist. And really, in the context of zero trust, the way we use Vault, the guiding principle for Vault is that notion of identity brokering. This is our nirvana state where we go into Vault with a well-known and established identity, and then Vault would broker the identity, dynamically create it and the required credentials and keys at the target platform, at the database, at the resource, at the Kubernetes cluster, at the cloud provider, or whatever else. And really think of the notion of the inflation, right, of identities and secrets and keys over the last few years, driven mostly by the rise of microservices and new technologies. Right? So if you had a monolith and you kind of manage it with a username and password, you now have 7 or 13 different microservices, and they all need to have their own accounts, identities, secrets, keys. Extremely hard to manage. It's very cumbersome. It's very complicated. So basically, we just put Vault there and hide all this complexity. You go into Vault, well-known identity, you authenticate, you authorize, you go through a policy check that you are allowed to do what you're asking to do, and then Vault will broker that flow for you. You don't need to be known at the target resource a priori. So that's the power of Vault in the context of zero trust. Okay, so now we know who we are dealing with, right? We established this identity, and we want to make sure that the connectivity, the access between different machines, different processes, different services is secure, and this is where we use Consul. Consul is our network service networking solution, right? It's a tool to automate network workflows in a secure way across any technology stack and any existing cloud provider. Consul 2 solves 3 main use cases. And generally speaking, if you look at our products, we have this notion of crawl, walk, run. Any of our products are very easy to start with. And then as the usage gets complicated, you can advance the features and setup that you use from our products, crawl, walk, run. And in this case, the crawl, walk, run is that you typically start with Consul for service discovery. So now think about Consul as a registry with a view of all the services in the network, and add to that health awareness, right? So console knows what service exists where, and if services fail, it will take them out of circulation automatically. And then usually you expose that view with the DNS API, right? To kind of like implement the very first step of service discovery. Sometimes also with a feed, extract a feed from console into a CMDB platform. Typical problem that CMDB has is that it doesn't cope with the scale and the dynamic nature and things coming and going. And if it's there now, it's not there in 3 hours. CMDB was designed for slow moving and scale is okay, but it's typically slow moving environment where you provision something and it takes a week, but then it stays there for 3 years. With cloud and the dynamic ephemeral infrastructure, console is very good with kind of dealing with all the low-level movements, dynamic movements, and then you do an overnight feed to CMDB or something like that, right? The next use case is the service mesh. And service mesh really, it too is a complex topic, but in essence, think about taking the 2 main functions that are done by appliances today, and this is the security and the indirection, right? The firewall and the load balancer, and kind of decentralizing them, distributing them, and doing them at the edges with software, right? So there are no appliances and they're not centralized. And console would do that and create secure TLS connectivity between different applications, different services, all policy-based, right? And the third use case is what we call the network infrastructure automation. And then this kind of like really goes back to the second use case. While it is advanced and it supports modern setup, we're also quite sensitive to the fact that there's existing setup that needs to be there. And those appliances that we are decentralizing, which is a great term, or democratizing, they're still there, and we need to work with them, right? So a typical, like a very annoying workflow is that you have everything automated, you get to the network, and then you need to wait the 8 to 12 weeks for a firewall poke. So this is where NIA comes in, and then Vault, either directly or indirectly through Terraform, integrates with firewalls, with the Palo Altos and checkpoints and F5s and so on of the world to complete and automate the last mile, right? So when there are movements at the runtime, proactive or reactive, be it provisioning or failure, then console through Terraform would go and make sure that the environment is updated and no interaction, no human activities is required, right? I coined the term ZZZ, not for sleeping, but it's for zero trust, zero touch, zero downtime. And it's early days, but this is going to be a game changer for how we kind of complete the end-to-end automation for infrastructure. So to summarize console, right, the guiding principle here is to do the application-based networking, and it's all logical, right? So instead of saying IP1 allowed to connect to IP2, you now say service 1 is allowed to connect to service 2. Sorry, service A is allowed to connect to service B. And when IPs are realized, the rules will update. And when things are moving and changing at the physical layer, the rules don't need to change. Right? It's this notion of we elevated now from network and physical to logical and application-based networking. All right. Last but not least, I'm going to talk about the human-to-machine interaction, right? And this is where we use a Boundary. Boundary is a new tool that we have. It's available now as an open source, and I'll kind of explain a little bit about the philosophy of Boundary and how it solves the problem in a different way to what is available today, typically for human-to-machine access. So I'll kind of describe a flow here, existing flow of human-to-machine access. I'll touch a little bit about the pain points and then see how Boundary helps. So a human on the right wants to access a resource. A human on the left wants to access a resource on the right, first thing they do, go through a VPN, right? Even on-prem, you go through a VPN. And the problem with VPN, the challenge with it, there's no problem with it. The challenge with VPN is the onboarding, right? It's you need to distribute some key, a token, or some RSA key, and it's risky, even more so risky for offboarding when you need to collect it from someone who should no longer have access to the VPN, right? So it's slow, costly, and fairly risky. But then once you've gone through that, you're now on the network, which is okay because you want to access the network. But really, if we're now with attackers on the network and zero trust, we don't want people just roaming around the network and doing stuff. If we can avoid it, let's not give them access to the network. So we want to kind of call out this challenge of having access to the network. The next part, you can think of the gate. And it would typically be also IP-based existing security appliances. There'll be a jump host, a firewall, IP table, whatever else. And then the challenge here is that it's brittle, right? We talked about it earlier in a different context, but it's brittle because when new IPs come up due to a failure or provisioning or scaling, you need to go and update those physical IP-based policies. And the last point is that for that human to have access to the resource, they need to be known at the resource, and they need to kind of keep some username and password for the database on some post-it note or whatever else, and access you have the risk of secret sprawl or sharing and compromise and so on. These are typically long-lasting credentials. So then we're going to solve all that. So then we kind of looked at, this is how Boundary came to life, right? We kind of looked at it and realized that it's a solution that was designed for high trust and slow moving environment, right? The VPN, the access to the network, the IP brittleness. In a slow moving environment where everything is highly trusted, it's okay. But in a low trust, dynamic, fast moving environment, it's not so okay. So then this is how Boundary solved the problem. Same flow, right? The user wants to access a resource. User on the left, resource on the right. So no VPN, we'll just kind of piggyback on the single sign-on, right? Going back to the very first box I described. We piggyback, we connect to the single sign-on identity provider that the organization has. And then the next step is that through role-based access and various policies, time of day, location, who the individual is, the role, and so on, they will be presented with a list of resources that they can access, interact with, which is dynamically updated as the reality changes. Right? So it's a logical list, but when there's a new, when think of Terraform provisioning something, there's a feed from Terraform to update the list of resources. Or when something moves on the Kubernetes environment, the list will be updated. So it's a logical policy role-based list that is with a feedback from the physical deployments. And then, so now, we kind of go and select the resource. And at this point, there's no access to the network. Boundary will create a link between the user workstation, laptop, to the resource. Right? Logically speaking, think about it as an SSH on steroid, SSH tunnel on steroid. There's no way to access any other network device, compromise anything. It's just a direct link to the resource, point to point. And then the last bit is the actual access to the database, let's say. And this is where Boundary would ask Vault for help to dynamically create the identity and the credentials with a short TTL span to satisfy that session. And then when this is done, the whole thing collapses and there are no traces. There's no way to compromise, take advantage of the identity, credentials, network, devices, or anything else, right? It's just completely cleaned out. So I'll summarize the Boundary flow, right? This is how it looks like. The high level, a user comes in, does the authentication with a single sign-on provider, identity provider. And then we kind of authorize the interaction with policy-based rules. There's a bunch of rules that we look at. And then the last part, either directly to the resource or through Vault, Boundary will create the necessary setup, identities, and credentials to make the session happen. All right, so it's summary time. So the main point here that I want people to keep is that move from IP-based control, IP-driven control, to identity-based controls, right? Physical IP to logical identities. That's the overarching principle and the single most important point of this presentation. And we do it, we kind of break the problem differently to human and machines, and we have different products operating in each of these boxes. And I think that this concludes my presentation. And I'm going to stop my screen. And I think next we're going to go into a panel and just kind of answer some questions myself and the rest, right? So we'll start with Johan and Carl. So first of all, thank you very much for joining us for this panel. And if you don't mind, just kind of starting with introducing yourself, your context to Zero Trust, what you're doing, and what would be good to talk about. Johan, maybe you can start.
Sure, Guy, thank you very much, and thanks for having us today. Just by introduction, Johan Murray from Discovery Health. I represent the Platform as a Service division, which is a central function as part of the Group Information Services offering. Discovery is by nature a federated organization globally. And in context of today, I represent both the consumer of the technologies and solutions we implement, but also somebody that has a role to play in enforcing and working closely aligned with our security team to help enforce such practices. Because part of platform services in my space, we are part of the problem per se at some points, because we adopting clouds at a rapid pace, DevOps practices, containerization, all the buzzwords you can think of is something that falls in my space. And therefore we have a role to play to help make sure we do this in a secure manner, while at the same time improving our posture. Just a little bit about myself.
Hi, I'm Carl Fisher. I'm CTO of Obsidian Systems. We're a long-time open source implementation partner of HashiCorp. We love the tools. We love using them. We're using them in-house, and obviously we consult around them. We have a few internally developed applications that rely heavily on things like Terraform and Vault. Obviously, we're working in all the different cloud environments. So obviously for us, working with credentials and credential sprawl, especially when we have devs working on our stuff, is kind of important that they don't necessarily have all the access to everything, all the keys to the kingdom. So we try to help customers to obviously get their workloads in the cloud in the most efficient way, and obviously not trying to lock them into a specific cloud environment. And we obviously see the HashiCorp tool chain as a good way of abstracting those kinds of workloads for customers so they can run anywhere at any scale. And it's just we just like using your tools. So I just made a few notes here. Thank you, Guy, for saying those things. It's also, I love that acronym ZZZ. I'll take that. So it was zero trust, zero touch, and zero downtime is probably something that most companies want. And I was very excited. I'm very excited for some tools like Boundary, especially because I've had pain with the competitors' tools, and nobody likes those tools. Nobody likes to use VPN to get somewhere. It's terrible. It's ugly. It's messy. And one of the bad things, especially with these since we're in the time that we're at, is that our workforces are distributed. So onboarding people to different VPN credentials, waiting for that time, making sure they have the right access, then determining that they don't have the right access to the things is a constant battle. So we're very excited to see what role Boundary will play in the Hashi stack. And yeah, that's just a bit of an introduction from me.
Yeah, that's great. Thank you. You know, this ZZZ, I shared it with some of my American colleagues, but ZZZ is kind of, it's a way to say that you're sleeping. So, but in all honesty, I think it's the first time, and I shared that in previous webinar, it's the first time that I can envision a full automation that is absolutely zero touch, right? When something happens proactively or reactively, you just kind of put the capacity, you move stuff there, you make sure that all the appliances are up to speed with what needs to happen. And, you know, it reduces the risk significantly. Yeah, and you know, thank you for the kind notes. I think Boundary, it's only available as open source now, but please feel free to use it and kind of enjoy it and give us feedback. It tries to bring our, the way of HashiCorp doing stuff and modern and new and, bottom up to that human to machine access, which traditionally was cumbersome and, slow and annoying and, enterprise with tools. And so it's exciting time from that perspective. We have a few, but before I start, just for the audience, if there's any questions, please feel free to put on the chat, on the Q&A for Johan, Carl, myself, or anyone else from the team.
Or me, if they want
to address. Yeah. And Lance, yeah, if we'll try to address. Otherwise, I want to ask you, I have a few pre-submitted questions that I want to ask you, and I want to start with, so this talk is, it makes sense, right? I'm a little bit biased, but people subscribe to that vision, right? Everybody wants to be more secure, more dynamic, more new, right? It's and typically the question, one of the first questions that we deal with, and I want to kind of pose it to you as well. How do you start? Okay, so you want to be with dynamic, ephemeral identities and boundary. How do you start? Like, look at what we have now. We have all these existing stuff. We have procedures, processes. Tell us how to start. And I think it's a question. It's a good question also to start. So maybe we can start with that for either one of you.
So, Guy, happy to have a go at it. I think, like for all of us, zero trust is real and it's a journey. We have to start somewhere. For us, I suppose it has always been about the identity, the centralized control over authentication and authorization. That has been the starting point for us. And for us, having that capability is then expanded by then focusing on a strong application register. So we can understand where does the application fit into the zero trust strategy. For existing organizations and enterprises, big or small, doesn't matter, especially that one that has got legacy deployment models and so forth, it's not an easy change. Adoption, change control, change management plays a big role as part of that. So for us, we started focusing on the authorization or authentication, and from there on kind of build out. As we learn and as we show value on the strategy, then obviously pace gets picked up, but it's by no means an easy task. You have to start somewhere, and like we always say, you can't chew the elephant all at once. It's one of those approaches, like take something small, start and iterate on it. That's been our experience thus far, and to the point, it's still a journey. It's an ongoing journey.
What did you say about the elephant? Can you repeat that? The elephant bit?
So it's this concept of eating an elephant in bite sizes.
Oh, eating. Yeah, it's too big to eat in one go, right?
Correct.
Yeah,
okay, I got it.
Eat the elephant one bite at a time.
That's it.
So yeah, I agree the sentiment from Johan. I think I think for us, it was easy to identify some of the places where saying that what is the most smallest step we can do for the most maximum output, so the biggest impact for the smallest amount of effort. I guess it falls a lot in line with the way the Tao of Hashi, like I think, like how do we codify things, how do we automate things, how do we just try and get things, remove the humans from the equation. But that's a sensitive topic. But I think in the whole security pipeline, we're probably the most fragile bit of everything. And also for us, when you identify these areas, is always the thing is that what would cause the most reputational damage should that break or leak. If you look at things like Equifax and things like that, ooh, that hurts. I think that's the kind of places that you would need to try and identify where would it hurt the most when things break, or when the trust is lost. Where's those specific areas to focus on? So yeah.
I've got a question that actually feeds on from that, if you don't mind. I've noticed in my kind of interaction with customers, a lot of people say that there's a struggle internally to change the perception of how this should be done, purely because people are concerned about perhaps a change to their working environment, a change to their ability to do their job, where in actual fact it actually just changes the job they do, not necessarily takes it away. Have you had that kind of struggle? I think Johan, I'd like to ask you first, purely from what you've been doing with your obviously being discovery, and then Carl, I'd like to, from your point of view, the other way around, right? How does it do to try and transfer that message? If you wouldn't mind asking that.
No, sure, Lance. I think for us, I alluded to it earlier, it's a journey, right? And change management is key. This whole approach of people not wanting to change, when you start changing them, they see it as red tape, potentially. It depends on how do you market it and how you show the value to the organization for this. For us, it took up to 18 months to start showing real big value at a scale where we have support top down with the changes we implementing in the organization. And as soon as we start showing value and demonstrate the benefit of what we're doing, it seems to be a much easier task.
Yeah.
Because security is a heavy topic. It's a costly topic. But not having all the answers, by starting somewhere and then showing the value and making sure that change management is followed through, has shown value for us. We've seen positive results. And now that we've shown those, it seems like it's an ongoing exercise, but the adoption is also a much easier pace. We get less kickback from businesses because we have a common strategy.
Yeah, no, that's definitely, I think, a common theme. Sorry, Guy.
One thing I would add there, just to augment what Johan said. I think Carl said it before. So, you want to move people out of the way, and like, this is really what you want to do, not because you don't want the people. You definitely want the people. The organization needs to create facilities to reskill people and kind of allow them to add value at different levels to the organization. But you want to move them out of the way, basically to reduce risk, to reduce threat fingering, to streamline and industrialize processes. It's not a bad thing to remove people out of the way. It's a good thing because like we think of different transformations over the history, right? I mean, I don't know, a typical like laundry. We used to manually launder clothes, and now it's all with a robot on a washing machine, and we now have time to do something else. Those people that manage and use the console and do all these things manually will do something else of greater value, hopefully more interesting, but it's not something that will just happen. I see like organizations who create the frameworks to help individuals upskill and reskill and retrain have better chances of having people go along that route.
Mm-hmm. Definitely.
Less concerned with job security and the cheese that moved and all these things that we don't like, right?
Cool. And Carl, your opinion from your experience?
I think people are perhaps inherently afraid of stuff that might take their job away.
And rightly so.
And that is fine. That's fine. That's fine. And what we try and just promote is to say that there used to be we can take a simple password change across 2,000 servers as an example. You could go and do it manually 2,000 times, and that takes time. Or you can change it in a central place, and that password gets changed and pushed proactively to those nodes. It's your time. You can spend it at whatever rate you want to do, and it's that. Or we can try and say, let's remove the toil of day-to-day operations and improve your life. Because if your life is improved, you can focus on the things that is important, the real important, the innovation, the development. You try and reduce that cycle. So for us, it's usually we lean heavily on there's a book called The Spirit of Kaizen by a guy called Robert Maurer, and he basically says in that book, is like, what small incremental step can I do to make a maximum impact? And it's all these small steps collectively that make a lot of changes. And so what we try and say to customers is to say, when you approach a piece of technology, don't necessarily say it's a big bang approach, right? Just try and store some stuff in a secure vault. The important things of how people interact with a piece of storage in the cloud, those credentials, those things, just keep it separate. Don't go big bang, and then see if that is a easier pattern to implement, and then build on those specific patterns, because you'll see that those patterns start building up. And those people obviously, and that's partly because of also the Hashi suite is so easy to learn and so user orientated that people, as soon as they understand how the one tool works, they probably start leaning on, like, well, if it works like this, I think this tool's going to also start working like that. And then you start embracing stuff like Sentinel policies that work across everything, and then you really take hold of that power that just leans across the entire stack. And we're trying to encourage people to say that at least try, you're going to save time and effort eventually, and it's a new skill that you learn. It's something that you can take with you. It's not necessarily, we're not taking that away from you, we're teaching you something new.
Yeah, definitely. And
actually also goes back to Johan's initial point, right? I just took a note because I wanted to come back to it, and I think these 2 points kind of flirt with each other, because you kind of said that you started with credentials and authentication, right? And kind of, we call it the secrets hygiene. Secrets hygiene is something that just makes sense to do, regardless of cloud, before you go and start with dynamic stuff and just kind of onboarding, implementing Vault, moving, this is a small step that you do and realize immediate value towards that vision of zero trust.
Yeah, definitely. I think. Oh, and I've got a nice question here from the chat, the attendees here. So maybe this is something a little bit more of a.
Sure.
So yeah, Edmore asks, with the movement from IP-based authentication to service-based authentication, isn't it good to always want to know the device connected to your network? Who wants to take that one? I can start if you want me to start, to give you time to think about the answer.
Can you explain it? Because
yeah, so I think from how I read it, and I hope I'm doing Edmore justice here, is like when something joins your network, you want to know what that thing is that's joined your network, and this relates to our always think that something is compromised. If your have that mindset that you're always compromised, and then protect the data that way. So I think the question is, isn't it good to know what they are beforehand, before they join your network? And we're looking at traditionally around MAC address blocking or a system identification, using that old kind of way of thinking. But it's just not a feasible manage to maintain that if you've got machines joining the network every now and again. So that's my perspective on that. I don't know. Anybody else? Carl, Johan?
So
I think.
Carl.
Oh, okay. I'm Carl. Okay, cool. I'll be called now. You can be called later, okay? But a good joke. Anyway, so obviously the principle of least privilege is probably the thing that we should go here for. Is like when something joins your network, what does it have access to by default? Is the entire subnet open for you to go and explore? What service discovery is that? This is stuff about service discovery. That's stuff that we need to talk about. And the other thing is like how abstracted is your network from other bits and pieces, right? So that when you might have a bad actor, what does this person have, or what does this device have access to, right? And then that was specifically related to like exactly the human to machine authentication layer or the machine to machine authentication layer. So that's just where I would set the stage now.
Yeah, I think in our context, and it's a real problem. I think when you're small, it might be more manageable, but as you grow and scale and go global, you have developers from all over the world contributing to your source code. And the notion of controlling everybody's endpoint isn't really practical. It's a common problem. So we have to find better ways of doing with this. And to Carl's example, least privilege access and better automation processes and DevOps practices around it then gets forced, because instead of having the humans that traditionally would deploy code or copy artifacts to servers, you have to find better ways of doing that in an automated fashion to circumvent the need for understanding or having a control of the posture of the endpoint, because most of those times they're also not your employees. And the practicality of enforcing your own group standards on third parties isn't really viable. So it's a conundrum to solve for. So you have to find the simplest, most effective way to not make the developer uncomfortable, waste his time because he has to jump 15 hoops to do what he needs to do.
Yeah.
And come up with better processes to solve for that.
I want to also have a go at this because I think it's a very interesting one. My view is going to be a little bit maybe slightly different, but let me kind of walk through how I see it, and it really is affected by our approach, right? So I'm going to treat this differently for human and for machine. First of all, for machines, there's this notion of self-discovery or self-advertise. It's the same problem, right? I mean, it kind of looks simple to say, all right, I don't want to configure and everything is static. I want things just to start and they will join. They will join the cluster, they will join the zookeeper, the HA proxy, they will just join. And if you try for discovery, it's okay. But if you try to implement that for zero trust, then, kind of raises a question. Stuff just kind of wakes up and joins and be able to connect the firewall and load balancer. And, that's a bit scary. So my answer to that is that, yes, we don't want things to just autonomously, there's a level of autonomy that we want to give the machine, but it's not completely random stuff that comes and, right? So let's just break it to when these things happen. Like we have a system, the system is provisioned, we're now in day 2, day 3, day 4. Is there something proactive that is happening, like we're doing a repave, or there's some sort of failure that is happening and we need to move stuff? Regardless of proactive or reactive, these things, we human developers and engineers, we codify in the system how to behave and what to do when these things happen. It's not completely autonomous. For example, we'll run a CI/CD workflow and we'll trigger a Terraform to go and put more capacity, and that capacity will now automatically join through the console Terraform sync. Or if there's a failover and we move to a different machine, that machine is ours and it's part of our secure area, and it'll be presented to the firewall and load balancer. Right, so that's kind of the first part. With human to machine, it's totally different. Human to machine, no one just joins. Right? I mean, it's the Fight Club. First rule is you don't talk about Fight Club, and you can only be invited to Fight Club. I cannot access the role-based system and give myself access. But someone needs to enable me. So, that's what I mean. We treat it very differently, machine to human. human is easy to kind of envision because we know who we are dealing with and we manage it and control it and we invite people in. For machine, we give a level of autonomicity, ZZZ, but it's at the high level, we human control the platform and we kind of give it enough leeway to do the right thing without calling us at 2 a.m. because there's a failure. But this failure is something that we have designed to the configuration, to the application, to the it's a failure that we catered for. It's not a completely random machine that just shows up and joins our secure network. Right. So this is like maybe a little bit of a wider answer to that things that just show up and join the trusted network. That's my view on the topic.
There's a question here, Guy, and I think I'm going to ask for the panel. We've only got 5 minutes, so we're going to cook on gas here.
Sure.
It says, I have a question around getting business buy-in. I think it's a bit easier to convince devs or architects about the necessity of new tech, but now you have guys found, well, have you found, let me try that again. How have you guys found these conversations to be with the business? The people that always have the items that are more urgent and important. Yeah, so what I think is like the business really pressurizes you to get this done.
Yeah, right. Look.
Well, let's call, maybe Carl can take this one, Guy, and then we can let Jan do that afterwards. Carl?
Yeah, so again, it comes down to like reputation damage, right? Usually when business, when you show a piece of technology to engineers, we're very keen and very cool. It's like, it's amazing. You have to see it, you have to use it. But business doesn't necessarily understand the necessity of something like this. So when you go to business, you say, oh, I want money for X, Y, Z. Business says no, right? Because they don't see the value. However, as soon as you start working with something with zero trust, that conversation flips, because usually an engineer or a person on the lower levels might not be responsible for that. But if the organization gets compromised or something might happen and it affects reputation, then C-level starts getting involved by default, right? So usually when you start with a security type thing, or when you want to implement something, you start working on that level and say, like, this is going to increase our security posture. We're going to make sure that X, Y, Z is in place. This is going to help us enforce the stuff. And we've seen that if you start speaking about security, and usually after a compromise, suddenly this budget that wasn't available, there's no money, suddenly comes like out of nothing with money, right? And you have to always pitch it to business in that way. It's like, will there be money after this incident has happened, or can we rather spend the money proactively now before there's an incident? And I think that's a good way to approach it. But I want to hear from Yuan. I think he's got some valuable insights.
Carl, you're pretty spot on there. I think as techies, you're 100%. It's easier to convince them to start adopting new practices and embrace new tooling, especially if it makes their life easier, right? However, security is a touchy subject, and I alluded to it earlier. It comes at a price. There's this plethora of tools out there, and part of adopting strategies like zero trust is because you can't keep up with the constant spend that's demanded of you with, I don't know, call it a handful of tools, if it's 100 or 1,000, just to try and protect yourselves better. From our perspective, I suppose the biggest one is you need the corporate and the board buy-in to say, this is our strategy, because you've either showcased through means of running through an exercise with them that showcase the risk and make it real, because I think that's very valuable, because not everybody understands it. It's a lot of technology talk, and to your point, people understand risk and reputational damage. And if you can demonstrate the reality of that and how real it is, and then get the commitment and buy-in to approach or adopt a strategy like zero trust, it's 10 times easier to then funnel it down, because the prioritization also then becomes a question of, do we deliver a new app quicker, or do we take a bit of extra time, but with having zero trust in mind? For me, it's a top-down thing, definitely.
Absolutely agree. It's a top-down thing. And also the organization needs to realize it's not a technical problem. It's an organizational challenge, and it impacts everybody, and you cannot solve it as a technical. It's like you need different areas of the organization to be bought in and supporting this program. You know, for zero trust and cloud transformation, generally speaking, right? There's so much you can do bottom up. It has to be top down with the proper support. Yep. And if that is not the case, then you need to do education and work on it so that you are successful for the long term.
100%. I think we always see it in the DevOps space. There's every tool under the moon that can do all the jobs, but it's a people and process problem normally. The adoption of new approaches, people and process. So that commitment to deliver a certain value and then the change management to help enforce that is absolutely key.
Guys,
okay, that's great. I think, yeah, hey, Justin, thanks.
Sorry to jump in there. I'm just playing timekeeper here. Super interesting discussion. Thanks, thanks everyone for the inputs. You know, a couple of things I took away from that is, you know, how do we get adoption rates within the business? You know, getting the C-suite interested in. You know, a very good point from Cole was around, you know, do you want to proactively look at this challenge, or do you want to do it, you know, retrospectively? And also things around, you know, right, we want to automate stuff, like how do we start? What should I automate first? There's some great inputs from Johan there. And so thanks everyone. Thanks Johan, Cole, Guy, and Lance. We're actually going to hand over to Lance now. Lance is our HashiCorp Regional Solutions Engineer. Lance is going to give us an overview of HashiCorp's roadmap to zero trust. So without further ado, I'll hand over to you, Lance.
Thank you very much. And thanks again for the great insight from the people on the panel. I'm hoping that, well, as Justin had said, really interesting discussion. And I hope everybody who wants to can join us later in the session afterwards, just to ask some face-to-face questions. It'll be really nice to understand and learn a bit about your situations and provide perhaps some guidance or advice. So thank you very much. Just quickly, I hope everybody can see my slides. I'm sure we can. We have a few minutes. As everybody said, I'm the Regional Manager for Solutions Engineering. I'm based actually out of Berlin, but originally South African. So just letting yourself doing that there. This talk is a roadmap to zero trust, and in this whole discussion and the way that we've been doing this, you will see that some of the topics I'm speaking about really align with what Guy's talk was about and what the general discussion was within the different questions and answers that we had in our channel about how does one implement zero trust. And what I wanted to talk about now is about how HashiCorp has been doing this planning towards zero trust before zero trust became a thing. It's just the way that our products have evolved, and I would like to kind of walk us through that. And then right at the end, I'll just give a more like a practical example using slides. I'm not a demo. I didn't do enough of the asking the gods to the demo gods today, so I'm going to do it just purely in slides. How a typical zero trust or transaction would take place within the environment, so that it might answer some of the questions that were in the chat earlier that I answered. Applied zero trust. What is applied zero trust? It's a living company-wide philosophy around securing the environments that are part of the company estate in a way that improves the overall security and efficiency of the company as a whole. And that's kind of like the gist of it. That's where you need to get the whole company on board to think zero trust, think identity, think I need to identify myself when I'm walking around and doing things within the company. We all have that now. You've got those badges you scan against the door when you do in an office, not so much now when you're at home, but now you've got other ways of identifying yourself. And these things that need to be applied, how one does it. What are the key concepts about applied zero trust, and how should you think about them? Well, there are three kind of pillars that are key to the start of your journey, which I'll go into in the next few slides. The first one is the principle of least privileged. Every user or machine must authenticate themselves and be explicitly authorized for access to the credentials, APIs, VMs, databases, you name it. They need to authenticate themselves. So that way you can find out, Are they who they say they are? And do they have the right permissions for the request that they're asking? And then the second thing is they should have just enough access for just as long as they need it to complete the task that they've been assigned. And so what this does is it helps prevent the breach before it even happens, because the secret is short-lived. No matter what it is, that secret should be short-lived. The application should automatically, whenever they need to refresh their secrets every now and again to get fresh credentials to connect to interfaces, and so the same for humans. The second pillar that we're talking about is never trust, always verify. And we're not saying that no one should be trusted. You have to trust people. That's part of doing business. What we're saying here is you verify, again, that the user or the machine who is requesting the access is actually who they say they are. So they must authenticate. They must always be authorized for the tasks that they're assigned. Because if you don't make sure that these are the people or the machines that are communicating with your system, there you know that some bad actor can jump in and imitate one of your users, one of your machines, or one of your services. And then the third pillar is always assume a breach. And we've spoken about this, and Guy alluded to it in his talk as well. If you assume your network's being breached and you work in the presumption that you can't get that breach out, so you have to protect everything from the get-go, which it should create a thought in the company's philosophy of continuously defend, continuously encrypt your personal information and data when it's at rest, assuming that someone is actually trawling your network and digging through your files to make sure that, or to try and find information. And this creates, by assuming this breach and this kind of mindset, you create a very small attack surface and attack time for any bad actor to penetrate or to gain access to your important systems. So to put these three on the slide together, for example, you can see that these topics, if you have them, you'll probably get the slides from us after this. Take this, print it out, put it on a board somewhere for your teams to understand, and just keep that in mind whenever you're designing a system, implementing a system, architecting a system, or reworking a current system, because this doesn't only apply to your new fandangled highfalutin microservices, but your old machines as well. You can actually do this for mainframes. It's convoluted, but it can be done. As we said before, and I think everybody's, Carl and Johan have alluded to it, it's a way of doing business, Zero Trust. And there are so many parts to this. Guy alluded to this a little bit earlier, that need to be covered to actually implement Zero Trust. If you think about it, there's so much that one needs to do. And so what I thought was I'll just grab this just-in-time access, because I think that's what we've spoken about. And I'm quite glad that we had some questions about it earlier, because this is where we're talking about what is just-in-time access. So this is one of the key ways to decrease your security risk in your environment. What this means is you grant credentials or secrets to humans or machines just in time. So exactly only when they need it and for the shortest time possible. Excuse me. So as always, when one does just-in-time access, as you will see, this slide matches very much similarly to what Guy has done before. You always need identity-driven control. So these will be how your people, the way that the machines and the system and the humans are authorizing themselves. So this is my identity store, and authorization needs to come from that identity store. So the first pillar, as we've mentioned before, is machine and authentication or authorization. Systems. So I'm reiterating this, and I think somebody was saying, but this is the same story. Yes, because it is very important. We're reiterating the fact that systems that are required to talk to each other should authenticate before gaining authorization to do the specific communication or action that they've been given. And this should be automatic and dynamic, so that your usernames and your passwords that the machines or the secrets that the machines are using are never the same for a long period of time, because that limits, again, the attack surface. By rotating these regularly, someone gets onto a machine, the stuff that they see on the system is already outdated. And there was a recent attack, or actually an expose written about one of the attacks, about how hackers got into a system what they did is they just compromised the system and read the RAM, and they had all the usernames and passwords. The person that last logged in, they had it in the RAM, and they could use that to jump to the next machine. And so they did it and carried on until they jumped around the whole network and compromised the network. So this is where you want these secrets to be short-lived. The next one is machine-to-machine access. So what you want to do is you want to make sure that your machines, when they communicate with each other, communicate over an encrypted link. Not just because you're connecting from your on-premise database to your on-premise systems to the cloud, but also on-premise to on-premise. So in the past, you would have them in these firewall zones, that you would have certain types of machines in the zone X and certain types of machines in zone Y, and you would have this firewall rule IP to IP communication. Now you have agent on the machine, and the machine itself talks locally to a IP address and a port. This is what I need to communicate with. And now I think with latest console, you don't need to do that because it just kind of proxies it anyway. And it sends off the request inside the TLS tunnel, and it's encrypted. So this is one of the things. The machine-to-machine access must be encrypted point-to-point and in an attention-based manner. So you allow all web services to talk to this database service so that they have access. So no matter how many times, hundreds of thousands of machines that spin up as web services, if they have the right tag, they have the right authorization, they can connect to the database in the backend. You don't have to do that manually by typing stuff or have someone do it. It just automatically happens. You just need someone to manage that, maintain the authorizations and the policies. Then obviously we spoke about earlier about the boundary kind of human to machine access. Again, this relies heavily on your identity-driven controls to make sure that humans, when they access, identify themselves, get themselves authorized, then they get access via policies to the certain tasks that they need to do. And I have a couple of slides later on to show you kind of like a practical example. And that is it. They don't have access all the time. They don't know the credentials, because my kind of mantra when I speak to some customers is, if a secret or a password or some access is seen by a human, it is already compromised. No matter if it's your CIO, CEO, whoever, if someone sees that secret, it's compromised. And so this is one of the key things that one needs to just remember, that they need to be short-lived. Human to machine credentials need to be short-lived. And I've lost my, there we go. And the last one is human authentication and authorization. So again, we've spoken about this. Your identity-driven controls are the backbone of this whole thing, and you would use single sign-on. And so somebody would would authenticate themselves, they'd be authorized, then you would use single sign-on amongst your different services to allow this authorization to continue on. And you want humans obviously to prove who they are. So you'd have two-factor authentication or some kind of dongle or something that people use, YubiKeys, you name them. There are many of them out there to solve the solution. So getting back to how HashiCorp has been thinking about this before it was a thing. Back in 2016, we started with Vault. And we created this highly resilient management tool. So, I mean, it managed secrets. It was kind of groundbreaking at the time. It was zero-touch identification. It had dynamic secrets. You could do dynamic databases and a bunch of things that really empowered teams to do what they needed to do within the environments. And in 2017, we kind of enabled more of the DevOps workflows and also the scale. We want to make sure that we scaled these out and created more got Vault certified with FIPS compliance, which is a 140.2 compliance for security and policies. And there's a bunch more since after that, but in 2017 we did that. In 2018, we literally became the market standard for secrets management. And then in 2019, we took this a little bit further. We added advanced data protection, encryption in transit, encryption at rest, format preserving encryption. And now that's something I will show you in the little slides afterwards. Masking, tokenization. There's a bunch of things that we added from 2019 onwards, and we're still adding now. Vault, the slide deck of mine is probably old now. I should move it on one more to 2021 as well, because there's some great new releases coming out on the product. And then we looked at console. Now we look at, remember, Vault came out in 2016. Vault came out in 2017, and it was just a service management backend with service registration, some service discovery, some health checking, and so on. And it kind of grew from that, and we realized that customers needed to do connect to multiple data centers. And so that's why we added the multi-data center kind of connect functionality, where we would be able to federate your data centers, your console data centers, so you can have a complete view of your whole infrastructure from one pane of glass, no matter which of the cluster centers that you're connected to. We then created Connect Envoy Proxy, so that allowed us to have Envoy sidecars in your environments and deployments. And then in 2019, we added the layer 17 observability, service proxies, and mesh gateways. And the mesh gateways kind of allow you to create a point-to-point, say, for on-premise to cloud connectivity, that only these gateways can communicate with each other in the old traditional manner of IP blocks. And then all traffic between console clusters goes between those. So it enables your, or simplifies your network configuration to a great detail. And then in HashiCorp Boundary came along in 2020. We had an initial release in 2020, and it provided initially quite a lot of things like TCP tunneling, multiplexing, session management, access automation. Then we came to 2021, and we've added some really great new features. And I think this answers one of the questions as well from one of the people that I've answered on the chat. We provided a desktop client, so developers can use this on their laptop. When they connect up, they say, hey, I want to connect to this database. They authorize themselves, and they can get connected into the database. We added OIDC, which is great because that's what we want for an environment where you can log in and prove of yourself and connect yourself to an identity system, as we've mentioned before. And one of the great things, we created the seamless secrets injection, which I'll show you a bit for that. The person requesting access to the system never sees the secret. It always gets provided by Vault, and a bunch of other feature sets, which I would like to, I would love to have talked on, but I'm running out of time. I've only got 5 minutes left on my time allotted. Excuse me. So what does applied zero trust look like in a typical transaction? So here we go. We've got an application. In our application view here, you've got a Go application, a database on the other side, and we have our Vault cluster standing there ready, prepared to help us out. So what happens normally, Go application starts up, and it says to, hey, Vault, I need some access to that database there. And Vault says, okay, I'll get you some secrets. Obviously, after they've Vault's determined that the Go application is allowed to connect to that database. And then the database will provide those secrets back, and we get a random username and password for that database provided back to the application. And then along comes our user. They're going onto our website. They're going to buy something great, but they enter in their credit card number. Yes, this is a fake credit card number. And they give it to the application. The application then passes that credit card number to Vault and says, Vault, please, can you encrypt this for me? Vault gives the number back, which, as you can see in the line below, looks like a credit card. It's format, and this is why format preserving encryption exists. It looks like a credit card. It has 4 sets of digits, but it isn't. It's an encrypted version of the one beforehand. And that provides the security that your traffic is now encrypted before you start connecting to the database. So what the application now does is it says to Envoy, hey, Envoy, I want to connect to the database. Console says, all right, I need you to, who's this? Oh, you're that Go application we spoke about, or I've been configured with. Yes, you're allowed to connect to the database, and then the traffic is automatically encrypted between the two. So then it allows the traffic through. The application then writes its text into the database in the format. So no table changes, no structure changes in your schema. It just gets written into the database. That's awesome. And obviously Vault has confirmed that these two systems can talk to each other and are allowed to do the task that they're allowed to do. As a benefit, on top of this, you have Vault's KMIP secret engine, which allows you then to encrypt the data files themselves on the system. So this would be if someone were able to take your system database files and walk off them out the door, which has been known to happen in the past, not so sure now, but if they were possible, you would be able to, they wouldn't be able to get to it because they would need your Vault, which is on the other side, to unencrypt the data. So as Guy mentioned earlier, this is seamless to the application. The application doesn't know that all this stuff is encrypted in the backend. It just behaves as if it's dealing with a standard database connection. And then we walked across to the users, how users are going to connect. So we have in this example, perhaps a database admin wants to go in and check something because the database is performing not so great and they want to see what's going on. And they request access, hey, to Boundary, I want to get database credentials for this database. Boundary goes away and does exactly the same as what it did before. Boundary asks Vault, please give the user some credentials. The user then gets his credentials via Boundary, so they never see them. And it's short-lived, and they are able to then connect to the system and look at the database and see how this work on the database as they would normally have done. This can replace VPNs, for example, because you don't need to have a VPN client. You don't have the VPN mux. You just have a Vault client, a Boundary client on your laptop or whatever, and it connects to the Boundary service that you have. And that, with 2 minutes to go, is my talk. Wow, that's good. It's a first for me. I didn't finish. I normally finish that early. Are there any questions?
Great stuff. Thanks for that, Lance. So any questions, guys, please just bang them in the chat. Lance, I've actually got one that's just come in here that perhaps you can jump on. And obviously, we are a bit pushed for time, but
yeah.
So I've got one that says, so they've got existing on-prem infrastructure. What is the best way, or how do I handle a zero trust approach to the cloud?
Yeah, so that's really great. I think it was mentioned quite earlier. Eat the elephant slowly. Start with the small parts, the things that you can automate and secure. For example, those secrets. Secrets are the easiest one to get through. You can start by putting your static secrets in Vault and making those secured by the access in Vault. And then going from there, once you start looking at the automation part of it, the dynamic secrets part of it, you can then slowly convert those environments. That for me is the kind of the easiest, shortest path to do. But always think and use it on the on-premise side as well. Think about you applying the same methodology, not only to the cloud services, but your on-premise services as well. Stick those secrets in a Vault that's managed by Vault and protected by Vault's solutions.
Okay, great stuff. Thanks. Any other questions? Yeah, we've just got one coming in here. I have a question around the credentials that Boundary provides to the user for DB access. Are these created as he makes the requests, or are they existing credentials stored in the DB?
No, they are created on demand. So these are dynamic credentials, and this is what makes it so secure. You could have a credential that exists purely for the run or the length of the request that's going to run. So the database admin or the system, for example, like that Go application, it will request a set of credentials. It'll get created dynamically, so they just exist purely for that one instance. After 10 minutes, for example, those will expire, and then the next request that comes through from the application will automatically regenerate a new set of credentials to allow it to then populate and communicate with the database. So the database, the secret's never around for longer than whatever you set, from 3 minutes, 5 minutes, 1 minute, whatever. It's really your choice.
Okay, awesome. We'll just give it another minute or so. Any other questions,
I
guys?
have a question, actually. This is Guy here. I wanted to ask.
No difficult questions, Guy. No difficult questions.
No. This is not going to be a difficult question. It's because I want to ask you about Boundary, right? Because Boundary, and I don't know if you have experiences or you have feedback, and just kind of, because I know the reasons why Boundary came to life, and I see interest at some level, in some respect, but I'm interested in what you see on the field, and if you see any differences between the regions on how they approach the user to machine. And what basically Boundary is very new, right? Yes. If there's something that you can share on how people think about the problem in a new
way. When we announced Boundary, I'm lucky enough that I'm working in 3 regions, kind of touching base on all, mainly Germany, but South Africa and a bit of the UK. And when we announced Boundary, there was a rush of, hey, come show us what this does. We want to work with it, because what we've seen is that most of the environments, the businesses that we work with normally, and some that we don't even work with yet, are interested, but they are interested in streamlining this process of providing this access with the most amount of visibility for themselves. But they don't have the manpower to do this with traditional kind of VPN-based technology, because what's happened is, and unfortunately, the current situation that we're all living in our lives right now has generated a lot of work from home scenarios. And companies are still struggling because they do not have enough people to do the manual process it takes to get someone access to a system that via a VPN, it just takes too long. Someone requests the action and a week and a half later, they actually get their access when they needed to solve a problem now. So we've seen a lot of this in the field where they want it now, as in, and obviously it was really new when we announced it. Now it's a lot more mature. It has much more feature set, but it's a drive towards making this flow and the workload on the people who manage access to the environment a lot less, by just creating these policies that someone can connect from Monday to Friday on this time, on this date, can connect to this database if they get permission from their manager, for example. I don't know. These are the kind of things that come to mind. So for me, the biggest kind of driver for this is simplification, automation, and obviously bringing that security model. I mean, we are biased, so I'm gonna. Why is my camera gone off? No, there's something wrong. Okay, we are biased around. You and I are biased about this because we believe about. We really agree with this. But when you bring this down to just core, take your HashiCorp hat off. How do I want to protect this network? You bring it down to that zero trust model. That really, I don't want to trust anything that doesn't need to be connecting to my systems. That's it. And people are starting to get that idea now. They're really, especially when we look into speaking to CISOs at that level, they are really driving, oh, I want this, I really want this. When is it enterprise? And it's great. I mean, that's, I don't know. Does that answer your question?
We are biased.
I can waffle for hours, you know me.
We are biased because we know, at least we both have many years of experiences working for enterprises, and we saw different ways of trying to solve the same problem.
Yes.
We're biased because we found a place where it's done nicely. So it does. I have a different question, but I don't know if Justin wants to chime in with a different question before another question before I ask mine.
I think.
So guys, we're starting to run out of time here, unfortunately.
Okay. Oh, well, we can ask Guy. We can ask it in the follow-up.
So there's another question, but we do. Yeah, we've got a follow-up session. So, just to wrap up, guys, I just wanted to thank everybody for joining and submitting these fantastic questions, and to all our speakers for participating. Johan, Cole, Guy, Lance, thanks so much, guys, for the panel. Marianne's put some contact details in the chat window around if you need to get in contact with HashiCorp to discuss anything further. But as mentioned before, there will be a follow-up Zoom session. Just in ending, Lance, there was one more question for you to know what the line of code was, code number 642 on the 7th page. If you could just tell us that. For the HashiCorp.
Not a chance. If you want to hear my answer, jump into the Zoom question, and we'll in the Zoom session. I'll be there now. So see you there to hear my answer.
Fantastic. Thanks everybody for joining. Much appreciated. And yeah, we'll follow up in the following session. Thanks a lot. Cheerio.